Good day everyone. We will continue discussing about memory on this video too. Every process that allocates virtual address space has private bytes and shared bytes. So as an example here, what I'm able to see is like as far as application R is concerned, we are able to see private bytes as well as shared bytes here. Okay, let's discuss what is a shared byte. There are some parts of the code that can be shared by multiple processes. For example, let's take a look at this particular notepad file. When I click on file and then click on open here, I'm able to see this particular open dialog box. Same way, when I open this MS Paint and then click file and open, what I'm able to see is like I'm getting a corresponding open dialog box. Now, when I compare this open dialog box with the one that is open for Notepad, what I'm able to see is like both these are kind of very similar, except the icon that I'm able to see here. So this is for Notepad and this is for MS Paint. Other than that, everything seems to be same. So what I understand is like, so any code that is basically going to be like used by several applications to achieve its functionality, in our case here, this open dialog box, all these things are kind of shared code, and these shared code will be placed on the shared bytes. With slight modification, that is, using a variable name in the common code that changes with each application to use the same code for several applications such as MS Paint, Notepad, PowerPoint, Word, and much more. So this code will be on the shared bytes of the memory, which can be reused by appropriate application. That is, the memory area which can be shared with other application or process and is called shared bytes. Let's discuss about private bytes. Private bytes, as the name implies, are process memory which are solely used by that particular process and at any point of time cannot be shared with other application or process. Let's now discuss about working set. Working set is a memory allocation for that particular process and that can be paged out. If you open Task Manager, memory that we can see is the working set value for that particular process. So if you look at any process here, what I'm able to see is like the memory that we are seeing here is basically the working set value. SQL Server has got two memory allocation model, and they are conventional memory model and log pages in memory model. We have large pages memory model also, which we will be discussing later. Let's consider we have 250 GB memory on a database server. Consider we have conventional memory model for the SQL server, which is the default memory model, and max server memory is set to 200 GB. Now let's consider SQL server is using all memory available to it. If you open the task manager and check for SQL server memory utilization, it will show it the memory utilization for SQL server process to close to 200 GB. On the other hand, if we have locked pages in memory model for SQL Server and max server memory is set to 200 GB. Now let's assume SQL Server is using all memory available to it. If you open the task manager and check for SQL Server memory utilization, it will show it as close to 1 or 2 GB. That is, the memory utilization by SQL Server on the task manager, it will basically be showing as 1 or 2 GB. Now, if someone updates you that SQL Server is allocated more memory, but it never uses more than 1 or 2 GB, I'm sure you know the answer for it now. As SQL Server uses log pages in memory model, the value we are seeing on the task manager is just the working set value of the SQL Server, and it can be paged out. But the allocation made by SQL Server using log pages in memory model cannot be paged out. What is this 1 or 2 GB that is used by SQL Server that is visible on the task manager when SQL Server uses log pages in memory model? This memory is used by your worker threads on a 64-bit machine. Each worker thread uses 2 MB memory. Link server queries, for example, you have a huge link server query. The memory used by that will be reflected here on the task manager. Log pages memory allocation will be purely for your buffer pool allocation. So to keep in mind, page allocation memory comes from log pages in memory area, and non-page allocation memory gets its share from the memory as shown in the task manager. Let's discuss what is conventional log pages and large pages memory model. Anytime SQL Server will start, it will reserve and commit the memory. Whenever SQL Server starts, it reserves the max server memory on the database server, but commits required memory only as and when required. For example, let's consider I'm planning a trip. So for this trip, I will basically book an air ticket. So this is an example for reserving. I will commit to it only if I travel on that day using that ticket. In this case, I have a plan for travel, so I will intimate the airlines and book a ticket well before, and that actually gets into action only if I travel. So let's discuss about the three memory models. So as far as conventional memory model, log pages in memory model, and large pages memory model is concerned, conventional memory model, we use virtual alloc for allocating memory. We will discuss about virtual alloc and other APIs in some time, but as of now, conventional memory model basically uses virtual alloc for allocating memory. As far as log pages in memory is concerned, we use allocate user physical page for allocating memory. And as far as large pages memory model is concerned, we use allocate user physical page API for allocating memory. Difference is it reserves and commits all memory as set in max server memory as soon as the SQL server starts. Page size will be 2 MB, and these pages cannot be paged out as we have log pages in memory set. As far as large pages memory model is concerned, it needs enterprise edition of SQL Server, at least 8 GB of memory. And as we know, log pages in memory should be set. And once the trace log 834 is enabled, we will be able to use large pages memory model. SQL Server will fail to start if contiguous chunk of max server memory value is not available on the database server. For example, let's consider the database server is running for several months or something. And for example, if you restart the SQL Server, there is a high possibility SQL Server will not start because it will not be able to commit all the memory that is mentioned in the max server memory. So because it might not be getting the contiguous chunk of memory, maybe because of memory fragmentation and things like that. Now, if you try restarting the server, there is a high possibility that SQL Server will be able to make the a commit for that particular memory what is mentioned in max server memory, and then it will be able to start it. And as far as conventional memory model is concerned, pages can be paged out, and log pages in memory and large pages memory model, the pages cannot be paged out because we have this log pages in memory option enabled for the SQL service account. Now, as far as the conventional memory model is concerned, you will be seeing a message called a significant part of SQL Server process memory has been paged out, and this may result in a performance degradation. So what it basically signifies is that whenever operating system feels like there is a memory pressure, it basically pages out all the required applications process memory just to make sure like operating system has got a good amount of memory. So as far as SQL Server is concerned, when this particular page out happens as far as SQL Server memory is concerned, there is high possibility all your costly pages and all your costly plans will all be like removed from memory, and that can definitely cause performance issue. So in order to avoid that, we basically what we do is like we enable log pages in memory model, and also like we need to make sure like there is no other memory hungry application on the database server that is actually required for the database server. Moving on. Let's look at what is virtual alloc and user allocate physical pages, and then we will take it from there. So as far as virtual alloc function is concerned, what we can see is like it basically reserves, commits, or changes the state of a region of pages in the virtual address space of the calling process. Memory allocated by this function is automatically initialized to 0. Now, let's look at the remarks and see if we can get more details on this particular thing. So as far as the remarks is concerned, what I'm able to see is like each page has an associated page state. Virtual alloc function can perform the following operations: commit a region of reserved pages, reserve a region of free pages, simultaneously reserve and commit a region of free pages. Virtual alloc cannot reserve a reserved page. It can commit a page that is already committed. This means you can commit a range of pages regardless of whether they have already been committed, and the function will not fail. So now let's look at the syntax for virtual alloc. So what we can see is like we are able to see like on the virtual address space using virtual alloc, we will be able to basically put in an address for this particular function, and then you need to mention the size, like how much you want as far as the VAS is concerned, and also the allocation type. For example, are you going to reserve or you're going to commit and things like that, and then protect. Basically, like you will tell like whether it is going to be read write or read only and things like that. Moving on, let's look at allocate user physical pages. So what we are seeing is like uh, allocate user physical pages allocates physical memory pages to be mapped and unmapped with any AWE region of a specified process. That is what we are seeing. And as far as the remarks are concerned, what we can see is like the allocate user physical page function is used to allocate physical memory that can be later mapped within the virtual address space of the process. The set lock memory privilege must be enabled in the caller's token, or the function will fail with this particular error. So this is what we are seeing as far as allocate user physical page is concerned. Moving on, let's look at the SQL Server error log. So this is a cleanly newly installed SQL Server. So now when I query the SQL Server error log, what I'm able to see is like let's look at the basically the memory model that I'm using right now. So what I'm seeing here is like I'm basically using a conventional memory in the memory manager. That let's try implementing the log pages in memory and then see what happens after restarting the SQL Server. So to enable log pages in memory, let me check what is the SQL Service account. So in my case, it is JBSWiki. So what I'll do is like I will go to the user rights assignment and then open log pages in memory and then add the SQL Service account here. It is added here. So now what I'm going to do is like I'm going to restart the SQL services. Let it complete here. It's stopping the service right now. In some time, it will start the SQL server. Just give it like another 30 seconds. Once this is restarted, what we'll basically do is like we will query the SQL Server error log, and then we will see like what is the memory model used. So right now it is restarted. So let me run this. Then let me check what is the memory model using. So right now what I'm seeing is like it is no longer conventional memory model. It is right now using log pages in memory manager. So now we know like how do we enable log pages in memory. So next one, what we'll do is like we will try checking what if we have what kind of things that we need to do as far as large pages is concerned. So right now we know like we have all the prerequisites here. So if I add a trace flag onto the SQL server, so let me stop it. Once this is stopped, what we'll do is like we will try adding a trace flag called 834, and then let's see what happens as far as the memory model is concerned. So I've stopped it. So let me try adding a trace flag called 834, and then let's apply it. So let me start the SQL Server. Once the SQL Server comes online, what we'll do again is like we will check the error log and see what is the difference right now. So if I look at it now, what I'm able to see is like I'm able to see large pages in the memory manager. So that's the difference. So initially, when the SQL services started, after I installed the SQL Server, I was able to see conventional memory model, and then I enabled the log pages in memory model by adding the SQL service account to the log pages in memory user assignment policy. And after that, what I did is like I just added a trace flag 834, and I was able to understand like once that was done and reset the SQL services, it is right now using large pages in the memory manager. So that's the difference. Okay, as far as the next question is concerned, let's understand, like, for example, when log pages in memory or large pages is enabled, let's consider we look at the task manager and we will be seeing like 1 or 2 GB memory utilization. So how do we know how much memory is utilized by log pages in memory and large pages memory model? So one thing is like to look at the performance monitor, and then let's do that now. So let's open the perfmon, and then if I add the memory manager target server memory, that will give us the information. That is one way of checking that. So I think we should go to memory manager here. Yep, here it is. And then if I go to the target server memory, so let's see what is target server memory. It is the ideal amount of memory the server is willing to consume. And what about the total server memory? This is the total amount of dynamic memory the server is currently consuming. So what we'll do is like we'll try adding this, and then we'll change this to a report. So what we can see is like it's in KB, so close to 4 GB is utilized by the SQL Server. So the other way to check this is like to run this DMV sys.dm underscore os underscore process memory. This give you good amount of information. So what it basically tells us like this is the overall physical memory used by SQL Server. And this basically shows you the large page allocation KB as far as SQL Server is concerned, and then this is locked pages allocation KB. So this is another way to check that, and another way is to run a DBCC memory status. So it gives you the information. So if you look at this, it basically tells you like how much physical memory is there, what is the virtual memory, and things like that. And what you will be able to see is like you will get good amount of information as far as memory is concerned. Now, if you look at this, what we can see is like we will be able to see like how much log pages is allocated, how much large pages are allocated. So you can either use this method, which is your DBCC memory status. The better way would be to use this particular query, and then you will be able to understand, at least to understand how much large pages or log pages is allocated for SQL Server is concerned. But to be frank, DBCC memory status has got wealth of information as far as the memory allocation is concerned by the SQL Server. It tells you like each and every clerk that is utilizing memory. You can get good amount of information from DBCC memory status. We will discuss about this on a different video, but that's it for this video. We'll continue discussing on memory on our next video too. Thanks for watching. Have a great day. Jai Hind.